This lesson is on tangent lines and how do we apply properties of a circle that are associated with tangent lines. So let's start off by addressing what the heck is this thing called a tangent to a circle. Very simply, it's a line in the plane of a circle that intersects the circle in exactly one point at this location that is called the point of tangency. So for example, if I have this point on a circle and there is a line that comes along and touches the circle in exactly one point, this point of tangency is this exact location right here. So the first theorem that we have involving a tangent, it says if a line is tangent to the circle, then the line is perpendicular to the radius at the point of tangency. Very important theorem right here. So here's my point right there. I've got a tangent. All right, so that's what it would look like. I know every circle has to have a center. And I know from that center to a point on the circle is known as the radius. This is my radius. What this theorem is telling me is if you have a line that is tangent to a circle, it must form a right angle right there with the radius at the point of tangency. Now this is very, very important because as we're going to see in a little bit, what this actually creates then is some scenarios that are involving right triangles. So just as a quick reflection on that, remember if it's a right triangle, that means Pythagorean theorem's in effect. That means special right triangles might be in effect. That means SOHCAHTOA might be used. We're going to focus primarily on just how is the Pythagorean theorem used. All right. So we have another theorem here. If a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then that line has to be tangent. This is essentially saying the same thing that the previous one was saying, except it's taking it from the other perspective. It's saying if you have a radius here, and this radius forms a perpendicular with this line, we'll call this line L. If a perpendicular is being formed right there, then L is a tangent. So if you're not sure and you see a radius meeting a line and a right angle being formed on the edge of the circle, that's telling you that that line has to be a tangent. All right? Now notice in the directions here, it says lines that appear to be tangent are tangent. So if it looks like a tangent, it is a tangent. All right? In this first problem here, I see that this is a right angle and this is a right angle. Why? Because I have two radii, and each of the radii is meeting this line that appears to hit the edge of the circle. Therefore, it is forming a perpendicular, and therefore we can call those tangents. All right. I have a quadrilateral that now gets formed. In order for me to find x, I know that x plus 90 plus 90 plus 60 has to add up to the four angles of a quadrilateral add up to 360 degrees. So this tells me x plus 240 is 360, or that missing angle, in this case a central angle, is 120 degrees. All right? If I take a look at this next picture, it looks like this is a tangent. It makes sense. Now there's three angles here. If there's three angles, I know it's a triangle. X plus 90 plus 43 has to add up to, the angles of a triangle add up to 180. So this would be x plus 133 is equal to 180, which means that x would be 47 degrees. All right? So there's some simple questions about it. Now, what if they move from talking about the angles to actually talking about the sides of the triangle? Sorry, I needed a drink of water there. Well, because a right triangle is being formed, that tells me that what I have to do here is apply the Pythagorean theorem. So in the Pythagorean theorem, I know that c squared which would be this entire side right here, or x plus 10 squared is equal to one of the legs squared plus the other leg squared. All right, now binomial multiplication. Let's do that off to the side. If I have x plus 10 times x plus 10. A lot of you guys learn this as FOIL. We're going to multiply this times this and this times this. In other words, we're going to distribute the x. Then we're going to distribute the 10 to both of those pieces as well. So when I do this, I get x squared plus 10x plus 10x plus 100, or x squared plus 20x plus 100. That's what the left side of my equation is. X squared plus 20x plus 100. And that's equal to x squared plus 14 squared, which would be 196. I'm going to solve for x, and one thing I notice is when I subtract x squareds are going to cancel out. So I'm left with the equation 20x plus 100 is equal to 196. Subtract 100, 20x is equal to 96. All right, and now I'm going to take 96 divided by 20. Let's see how that works out. 96 divided by 20, I know that x would be 4.8, and my directions say round to the nearest tenth, so that's perfect. If you notice, there are no units here on that particular problem, so I didn't need to worry about the units. Okay, this next problem here. Again, notice how big this hypotenuse is in this right triangle. It's x plus 7 units big. Now in this case, they gave me centimeters, so I'm going to need to remember that. All right, I'm going to apply the Pythagorean theorem that says the hypotenuse squared, x plus 7 squared, is equal to a leg, x squared, plus the other leg squared. All right, again, let's do this off to the side. X plus 7 times x plus 7. I'm going to distribute the x squared plus 7x. Distribute the 7, 7x plus 49. And this would simplify to x squared plus 14x plus 49. All right, so the left side of my equation is x squared plus 14x plus 49. And the right side would be x squared plus 100. If I subtract x squareds, they cancel each other out. So I'm left with 14x plus 49 equals 100. Subtract 49, so I have 14x is equal to 51. And divide by 14. And remember the direction said round to the nearest tenth. 51 divided by 14 gives me approximately 3.6. And the units that they use here are centimeters. All right. So the next question says, hey, here's a picture. It appears that 6, the line involving 6, is a tangent. Well, in order for it to be a tangent, the Pythagorean theorem must be satisfied. Right? So I'm assuming this angle down here is a right angle, which tells me in order for that to be called a tangent, I have to take 6.5 squared, and that has to equal 2.5 squared plus 6 squared. So let's go to the calculator to help me. What is 6.5 squared? That'd be 42.25. All right, go to the other side. What is 2.5 squared plus 6 squared? And that would be 42.25. That checks off that both sides are equivalent, which means the Pythagorean theorem is satisfied. And then I can claim it is a tangent. And that's all they're asking me to do, is determine if it's a tangent or not. In this next picture, I'm going to assume that the right angle is between the 5 and the 15. So then I would say, all right, is 16 squared equal to 5 squared plus 15 squared? All right, let's again use the calculator. What's 16 squared? 16 squared is 256. What is 5 squared plus 15 squared? Again, use the calculator. You don't have to. You could do it in your head too. But that gives me 250. The Pythagorean theorem is not satisfied. Therefore, this line, it is not a tangent. Okay? We have theorem 13.3 that says if two tangent segments to a circle share a common endpoint outside the circle, then the two segments must be congruent. So let me give you an example. Let's say that we have a tangent. And this tangent, there's the point of tangency, goes and touches the edge of a circle. If we have another tangent that intersects that, so let's kind of draw something like this. Bam! Hits off the edge of the circle. So that would also be a tangent. Then these two tangents are going to meet right here, and we're going to call that point A. I know that the distance from A to B and the distance from A to C have to be equal. AB has to equal AC if, in fact, these two tangents share a common endpoint outside the circle. That's what this theorem is saying. So how is this applied to a problem? Well, oftentimes what they're going to ask you is how do you find the perimeter of the polygon? Notice how there's a polygon and each one of these sides appear to be two tangents that are connecting or that have a common endpoint there. So let's start with the one that's 16 centimeters. There's its common endpoint. Therefore, that tangent segment and this tangent segment both have to be 16. From this endpoint, if that's 9, this has to be 9. From this endpoint, if that's 6, that has to be 6. And from that endpoint, if that's 8, that has to be 8. Now, here's the one thing that I always like to do here just to make my arithmetic a little easier. On the outside of each of these, so let's take the given one, 8 and 16. I know that that's 24. I know this left side is 14. I know this part right here is 15. And this part right here is 25. To find the perimeter, all I have to do is add up those numbers. So I have 24 plus 14 plus 15 plus 25, which would give me a perimeter of, yep, I'm going to cheat, 24 plus 14 plus 15 plus 25, which would give me 78. And because we're talking perimeter, my units here would be centimeters. All right. Now take a look at this one. All right. For this particular one, they give me this is 1.9 and then they give me the measurement of all the big sides there. All right. Here's what I know to be true. I know that this piece, because that's a common endpoint, this piece right here has to be 1.9. I'm going to have to go all the way around this circle and this polygon to figure out what this missing piece is over here. All right, well, let's see. If that's 1.9 and the whole side is 3.4, that means that this side is 1.6. Sorry, not 1.6. Oh, what am I doing? Well, not 1.6. Let me fix that. That would be 1.5. 1.9 plus 1.5 will give me 3.4. So if that piece is 1.5, this piece in here is 1.5. The whole side is 3.6, which means this side will be 2.1. If that's 2.1, this is 2.1. The whole piece here is 3.7, which tells me this is 1.6. Woo! And finally, I get this piece is 1.6. I know this entire length here is 3.5 inches. Now I can find the perimeter. I know the perimeter would be 3.5 plus 3.7 plus 3.6 plus 3.4. And I'm going to add those up on my calculator here. 3.5 plus 3.7 plus 3.6 plus 3.4. And I get a perimeter here of 14.2 inches. All right. I hope that helps. Let me know if you guys have any questions. Please complete the Math Excel.